Hello, everybody. My name is Lex Ransijn. I'm talking about two topics this afternoon. The first thing is that a project who won the Building Smart Award of 2018 for construction. And the other thing at the end is about, it's in Polish, but it's about the BIM PWI. We call it BIM Basic IDM. It's a kind of manual that we produced in the Netherlands, and we have translated it to Polish language. The project is in Amsterdam, in the Netherlands, and you see the city center. Maybe somebody has been there already. And in the left top corner, there's an old wood harbor. And we were importing wood from Finland, and we were collecting it there before it is being used for the pillars or for the houses that we were building. And it was like a redevelopment project where a lot of houses have been made. And our story is about the big project here in the corner. It's called Pontsteiger. And why is it called Pontsteiger? There was a ferry, and a ferry in Dutch is a pond. So, and Steiger is like a dock, so it was the dock for ferry, for a ferry. And the ferry is something what we have moved to the left, to the right. And there's an apartment with 366, a building with 366 apartments. And in the top floor, it's the most expensive apartment of the Netherlands. It was sold for 16 million. It was 1,440 square meters at that time. But later the owner sold several parts as an investment. So now it's not the biggest apartment anymore. But at that time we were thinking that was the most expensive apartment. And from the apartment you have a view over the canals where Amsterdam is famous for. And to show how we have built it in the last 2 years, I have a small time lapse made. You can see it's in the water. We first have to make a wall to pump out of the water. And after that, in the Netherlands, we live in a swamp. And so it's not strong enough to build houses on. We drill pillars into the ground, 3,000. And first we make the parking basement. And after that, our chief executive said, we have to build this building in 2 years. So that made us think different and to prefabricate everything. And as you can see, it's like one building story each week. So the towers raised one building story at each week. To make the bridge, these steel frames were sent to the construction site by vessel, by boat, from the other side of the Netherlands, and picked up by two cranes and put them on top of the 2 towers. So the construction of the bridge is like, I think, 1 week or maybe this part of the bridge. And to start a project like this, I was the BIM manager of a joint venture of 2 companies. It's called De Nijs and Dura Vermeer. Now I have my own company, VDC Base. And when I started working at that company, this was my desk. I had paper drawings. I had a laptop at that time, 2006. And we had a kind of old-fashioned exchange format where we were exchanging the information about the building projects with, it's called drawings on paper, with some hatches. And we had a very modern way to store all those files into the wall. And in 2017, we started with the first BIM models. This is a museum in the Netherlands. It's an old building of 1600 something. And to make that building suitable for a museum, there had to be a lot of steel inside. You see the BIM model here. So it's a BIM model for just only one discipline, the steel supplier. And after this project, I went to another project in 2009, and that was fully coordinated in 3D. We had like 8 different steel suppliers who were producing in several factories, all at the same time. So it has to be, and it was a shape which was not straight. So we needed to coordinate everything 3-dimensional. And at the project, you have a lot of participants, stakeholders, and we had like a list of people who are working for us. And I added one column at the end. And the column, if you filter it in Excel, you see this. How many software do we communicate for this project? So that's a list of like 10 different AutoCAD applications, and Tekla, TrueCAD, Revit already. And the common ground was that we were exchanging all those models in IFC. And I was coordinating that into a different program, which was coordinating IFCs. And unfortunately, we did some 2D issue management. So we also had the drawings, and I had to mark those drawings with my comments and do some redlining. And I tried a little bit in PowerPoint to do some 3-dimensional issue management. You see PowerPoint here. Sometimes this was more valuable for my steel supplier to give him some issues. And for the quantity takeoff, we used Excel. But almost all values are just typed with a computer. So it can be a little bit, you can make mistakes as a human. So it was a lot of work, and we got a lot of headaches of that process. Does anyone recognize the process of drawings, coloring, redlining, and then calculate it in Excel? I see some people laughing here. So my function was to implement BIM into our organization. But why BIM? Of course, to reduce the headaches on the project. And it was a company policy at that time, because after the project I just showed, my CEO said, we're going to do this every project over and over again. And yeah, we were thinking to build it in 2 years with all the prefab. It was impossible without BIM models. We wanted to save money on the project, also to speed up the construction. And there was no working space. It was in the water, so we didn't have any site around it to collect materials and do things like that. It was a skyscraper, and we wanted to raise the bar for construction engineering for our companies, and because we can. And last but not least, a shortage of labor power. So we don't have enough people to work on the construction site, so we have to do more things with machines of robots. So we kind of prefabricate, and to prefabricate you have to build it first into the computer, virtual. So we did BIM from the designers. The architect was also modeling until the end, but also to interact with manufacturers and back. So the frame you just saw with the 2 tower cranes was first assembled into the factory, then moved to the construction site. So that was one thing of the prefabricated elements. So we needed to make some agreements, and because it was a joint venture of 2 companies, the guy from the other company and me, we had to make one plan. And that's a good thing about a joint venture of two companies. You can do better than one company on its own. So we decided, let's put all our BIM protocols, execution plans, exchange information requirements together. And what's the core? What's the core? What's the best that we should agree? So we don't wanted to think about something new, but to combine several things, what's already working. And if you have the BIM levels, we have a national organization. It's called the Construction Information Council, who divided the BIM majority into several levels. And if you see my history working on BIM level 0 with paper drawings, I used that picture in one of my slides with the headaches. That was BIM level 0. Then you can do BIM level 1. BIM level 1 is that all the suppliers are making their models, but they are not federated yet. You see just like next to each other. So we decided we do BIM level 2. And from BIM level 2, you are integrated. You integrate the BIM models together and do the analysis with that. So you need two main files, as IFC and BCF. I saw a lot of presentations using BCF and IFC too, so I'm really happy to see that. And yeah, you have BIM level 3, and some people are thinking about what's happening there, but we decided this whole project we do on BIM level 2. So we needed to make some agreements with, I had less hair there on the right, but next to me there's the main architect, and these are the structural engineer and MEP. We started with that, a small team, but we had the end in mind. And the architect is not the only person in the project. We have so many persons, and we divide all the stakeholders into two parts. We call it demand, we call it the hamburger model. The hamburger model divides the design or the demand from the supply, manufacturing. We made a Dutch flag, red, white and blue. So I think all general contractors in the Netherlands work with this infographic. That you have the architect on the top, he make his model, and you have like paper drawings, some different information. Also the structural engineer, but also the suppliers. And everybody is involved. So that's the hamburger model. And to create a new execution plan, we had several already. I had some coaching lessons from a coach, and they said you have to look at the golden circle of Simon Sinek and tell your story always in the same order: why, how, what. So we decided to make a BIM execution plan on one page, on one Excel sheet, and we said, why are we doing this? How are we going to do this? What are we doing? Why, how, what? And to understand the project, we made an infographic which explains IFC. So IFC, you have a file with a site and a building story, and on the building story you have spaces. Spaces are into the requirements of the client, and around the spaces you have different objects to form the spaces, and they have different kind of information. So we try to explain to all the participants with this poster how it works. And if you do a big project like this, the first decision you have to make before everybody starts is how do we frame this project. So we decided day one, how do we split this model, because there's still not any software who can handle all the models in one view. So I've never seen this project into one viewer because it's too large. And we coordinate like the green part in the beginning. A month later, you do the red part, so you can manage that better. And we made some supporting documents. This one's for the architect, and the architect has to make some spaces, the fire rating objects, and we said for each object, which properties should be in the model. And a lot of software developers, they said to us, if you work with IFC, you lose a lot of information. And we proved that is not true. You only have to know what you're doing. So we investigated all software we are working with, and we came to the settings that you have to use to export a model without losing information. And another quite important decision was to follow the English properties which were described by Building Smart International. We are Dutch, we don't speak English, but we say if we translate everything to English and all the software has to be translated, we are busy for a few years translating it, and then we are already somewhere else in the development of the BIM levels. So we just follow the international standards. For example, for the strength of the concrete, we can use the structure class. Maybe, I don't know if you use these numbers too in Poland, but you might recognize it. So that's next step is the concurrent engineering. We gave the suppliers the contract before all the design was finished. So we came together with the architect and the suppliers how to detail the facade to prefabricate it. The architect cannot think it by himself. He has to get input from the supplier. So you have to decide what's in the model. So we have to collaborate with all the laptops on the table. How do we detail all these objects? And if you just start at one small part of the building, just a virtual mock-up. We also had a real mock-up, but we made a virtual mock-up before we started modeling the whole building. And at the end, we had like a structural design, we had MEP design, and we had, from the architect, we had 3 types of models: the facade, the interior walls, and all the space objects. And those were linked. So they were linked to each other. So if you have seen a drawing from the architect, you see the water pipes of the MEP design and the structural walls of the structural engineer. And yeah, this is really important for the architect, how to detail all those prefab objects from 2 sides. They were multi-layered, so it was not only concrete, but also insulation and the outside. So teams were working together to handle this. Every week they come together, solving issues to speed up the project. And to do the coordination, it's not only clash control. We have split it into 4 stages. And the first stage, we put it around the Hamburg model, is stage 1, that people check their own model. It sounds simple, but mostly they don't do it. They just send the model and good luck. But we say you have to check your own model, and on what aspects should they check? They should check about if the file of the name of all the building stories are correct, if the classification code is used correctly, if the local position is the same, and if there are no duplicates or overlapping elements, and in the middle, if the entities are correct. So step 2 is to coordinate the design. The design should be coordinated before we send it to the suppliers, because otherwise they have to solve issues that should be solved by the designers. So we link those objects, and we have written rule sets to check that. For this we used Solarby Model Checker, and these kind of issues were solved with that. Sounds easy, but sometimes it takes a lot of time too. But with a model, it's faster. And step 3, maybe it's new, but what we do is we say, this is the prefab concrete of the structural engineer. We're looking for a supplier. and the supplier has to make a model. So we first tell him these objects, in this case it's kind of prefabricated slabs. These objects, you have this square meter, you have to produce that. And for example, the facade, this was the design, this is the supplier, and if you look them together, you see a little differences, but they shouldn't be too much differences. You see here a little bit, but the outline should be the same. So that's for suppliers. And then all the suppliers has to be coordinated too. For example, we have like a prefabricated facade and we have a steel framing, and these has to be connected with two suppliers, and they had to be coordinated. And this is also all prefabricated on the left. So this is a concrete element with some anchoring gains on the right position, and then the steel frame supplier comes in, and then it has to fit at once. On the right, you see the result on site. You see this is all prefabricated, it's all aligned. So this was a dream for me that come true, that everything was fitting that great. And at the end of the project, we had 335 final IFC files, and it took us 3,381 to get there. So by average, 10 revisions for each discipline. And I think the architect had 50, and some suppliers maybe 2, but in average. So that's why we think that's BIM at its best, and then we signed up for the BIM award. Of course, there were issues to be managed, and issues should be managed with people. So don't forget the people. They have to get together, get behind the computer monitor and solve all those issues. We had 2 BIM. In the beginning, I did it with my colleague of the other company. We did the first 2 stages. And after the building permit, we trained 2 BIM directors on the project. There was Mark and Mike, and they were like the leaders of the project, virtual. And yeah, we solved the obvious clashes, but also less obvious clashes. That here you can see doors which cannot be opened because there's a steel frame behind. That's how the architect checked also his model. And it's not wrong to have issues, but you have to communicate around issues. And we used BIM Collab and the issue management in Sotheby for that, to exchange it with BCF. So we didn't need this tool anymore, but we did it in the computer. And because of, I think there were 32 different suppliers working different software, we used BCF to communicate all these issues. And this is an infographic of BIM Collab, which have some integrated BCF supporting tools. So the architect, he can log in with his own name, and he sees only the issues for himself. Saves a lot of time to search all the issues, only his own issues. And at the end, we had 6,036 issues, and not every issue is issued in the system, but only the main issues were there. But they took 2 years for that. And if you see all the MEP suppliers making models, we have like floor heating, mechanical ventilation, and electrical equipment. They're all in the model. And it's nice to have a lot of installations in your house, but to build it, you need a lot of provision and voids. So if you prefabricate a wall, you have to know before you produce that wall where there has to be provision of voids. So we also had models of all provision and voids, so that we can send that to the supplier, and then he said you have to make a hole right there, and right there. And all those barriers between different apartments, they should have a fire rating wall. You see here the black squares and here the blue squares. That's a different zone. So you have rooms or spaces, and these are rooms or space, but it's a different zone. There's in between, there should be a fire rated wall. And not only fire rating, also acoustic rating or thermal ratings, they should be in the model. And if you have good models, you can do the quantity takeoff. This is a typical Dutch thing. It's like pilers below the surface, two sandy layers on 20 meters, and some are 40. So we have different sand layers below the swamp. You have to drill really deep to get enough power to get big buildings on top of it. And for the client, it's really important that all rooms or spaces are there in the model with floor covering, wall covering, and ceiling covering. They're not all there in this model. And if you plan prefabricated, you have to do every 10 minutes in your planning. So we use the model for analyzing one building story. And then you can see that we also use like the temporary stuff in the model. This is also temporary, the yellow things. You see the safety here. This is the blue things. Now there comes the facade. And then the next level. So we didn't fully coordinate it 4D, the whole project, but we researched one story to decide if it's going to work. And it's also you see the purple stuff. That's also it's like a container with materials which are used inside the apartment. So it's quite difficult. And also the temporary stuff, it's in the model, like the scaffolding, the tower cranes, etc. And from the prefabrication and assembly, this is all prefabricated. You can see here. You can see some pictures: steel framing, concrete outside, inside, and you see here the vessel with all the steel frames coming from the other side of the Netherlands, and there is transported from the factory to the water, and then from the water to the project, and the project was on the water, so it was good to do that. And we had some frames which were also positioned in the model because there has to be some support in the soil to put these frames straight up there. Now you can see the process was modeled first, and then with only one bolt on this side, and on the other side also one bolt. It should be fit perfectly. And another object, we had some model of the structural engineer. We had the windows of the architect. Now this is the windows from the supplier, wooden frames. This is the architect's model. Some temporary stuff at the outside. Those were each object was produced and put in a temporary hold on the factory, and then transported to the construction site. And with one crane movement, it was on position. So that's why you can build a lot faster. It takes some time to engineer, but we were happy with it. This is the view from the tower crane during the construction. And also the construction site was modeled first. We had to do some analysis about how to drive around the construction site because there was water on the side, so we needed this extra corner, or this has to be visualized. Also the crane that has some strength on certain positions. We couldn't handle a too heavy element with the crane. We had some powerful cranes, but if an element is too heavy, we have to split it into two pieces. and also the how to anchor those tower cranes to the building during the construction phase should be there. This is where they talk about the trusses, anchors. And under the bridge, there was like a temporary scaffolding, a hanging platform. And of course, that was also first modeled because we needed some provisions in the steel frames to hang those things. And this is the result. This is on 60 meter high, was a temporary frame. So then we thought this is BIM at its best, so we signed up for the Building Smart Award in 2018, and we won it. And after that, I was invited on several places to tell this story. But for me, this story is already 4 years, 2 to 4 years ago. So after the story, we did a lot of other things. That's why I'm talking about right now. For someone who's not knowing where the Netherlands is, it's right there. But we also have the same problems as in every country. Model position don't match. Or this is an example of the name of the building story. This is the same project, it's like the same project on top of it. But the architect of the structural engineer, he said, these are my levels. This was the architect, he said, these are my levels, and this is the MEP. So that's not good for automation of processes. So we decided, this is me, and this is the guy from the joint venture project. This was from another really big general contractor of the Netherlands, to invite all other big contractors into one room. And then we started to play a game. We agree or we disagree. And then we were thinking, let's try to get to know where we all agree, what we all agree, or what we disagree. And that was my first thing after I stopped the former project. We started to do this because it was important. We have written down that day, but just one afternoon, what we all agreed. So there were arrangements outside of our CEOs, but all the BIM managers were coming together. What do we all agree? And we signed it. So we said, if all BIM projects in the Netherlands will be like this, we are really happy. And with this top 50 of general contractors in the Netherlands, we had like all these companies, and together we had like 60% of the total handover of the construction world. So we had a majority, and we produced an unbranded infographic. So no, you don't see any name or logo below it. And why did we do that? So that all people who are also agreed with this document, they can make it their own without having our logo there. Actually, we have translated it also to Polish with the help, I think, from the company who's organizing it. I'm not really sure. So these are the main agreements you should make on projects, like on all projects. You have different projects we can add things, but this is the core of a good project. And the main agreement is to share those files in IFC. So you can probably read this. I'm not, but I recognize IFC, so I say, yes, let's go. So our workflow in the Netherlands is like not vendor locking. So you can make a model in every software you want on top of it, as long as we can coordinate it with IFC files. And if we have all those IFC files, there are a lot of people who can join with free software. I spoke to the people of BIM Vision. It's a Polish development. BIM Collab is Dutch, and so to be, of course. And with all those models, you can do extra use cases. For example, to do quantity takeoff or do some 4D scheduling. But as long as you demand for IFC, then you can do a lot of other things. And you don't need one vendor. And for example, the three main agreements for a good BIM model is to make agreements about how to write the file name without the date, without the name, just a project and a discipline. Or the local position should be coordinated in between all the models. It still goes wrong on some projects. Or what's the name of the building story? If everybody agrees with this list, everybody has to use the same building stories, otherwise you have some problems. And the correct use of entities. Why correct use of entities? That you can filter the model on certain entities, but also if you use quantity takeoff, the surface of a wall, of a floor, slab, is the top, the area. But the area of a wall is the side. You can model really high floors, but looks like a wall, but if you don't tell it it's a wall, but he thinks it's a slab, then you have wrong quantities. And also every country has its own system classificatie. So maybe you have a system to classify objects for doing some budgeting, or we have a Dutch number. And also every object should have a material that you can color it automatically. And we don't want duplicates and intersections in our model, which are not allowed. And for example, if you make a wall in Revit and a wall in Archicad, there's always the property is external, true or false. You don't recognize it, but it's always there. And actually, we only say just check if the property is right. You can make interior walls and exterior walls. You have to handle them different. For example, to do some thermal analysis or other things, also for the planning. And also the same object, they all have load-bearing true or load-bearing false. It's very basic, but just check if they are correctly in the model. Fire rating, just mentioned, just fill in the number, 30, 60 or 90, and we can do with colors where are the fire rating walls, and so on. We have different objects. So if you're interested into that, we have an English part on our website. The BIM Loket is a Dutch government-paid organization, and you can download the Polish version of those agreements. And not only the Polish version, but also different languages around the world. We have French, Portuguese, Estonian, Swedish, Russian. Romanian is there already, but it's not colored yet. And last but not least, where I was busy with when I was working at the company, to make all the manuals, how to export those models in a correct way. I had my manuals, the other company had their manuals, and we combined the powers for free to make like national manuals that everybody can download, so that we can do other things than making manuals. So the most are in Dutch, but I think if you look to the screenshots, you can follow it. If it's not in Dutch, you can also download it on the website. We have a management committee. I'm the chairman of the expert committee about it. We are, I think, busy with 80 people with this. Not every week, but every quarter of the year. And we are not completely satisfied yet, so maybe we can have a revision to version 2. For example, I'm working on a large project with a lot of MEP, and I want to filter those kind of models with one click to see what the return error, how does the return error flows through this building. So we probably will add like one tile, give the system classification to the MEP object. So thank you very much for your attention. If you're not started yet with BIM, just start, learn from it, and share it with other people. And that's what I try to do. Thank you very much.